Hi, everybody. This is Indrasena Manga, and I am a senior data engineer at Access. Uh, so, you know, I'm sure nobody heard of Access, and it's spelled AXS. Yeah. So it's an online ticket sales and resale sales platform for uh, music and sports festivals. Now, anybody? Anybody heard of it? Yeah, a lot of, I see some fans over here for the ticketing. So, I'm sorry guys, this is my first ever talk in my life, and I am excited, and I am at the same time a little bit nervous, but I know you all been great people. You help me a lot. I receive a lot of tips from you guys, and I know I'll nail it in some time. Give it some time. So it's an amazing feeling to see you all in Austin. First, I'll tell more about access. So our systems have to handle massive and unpredictable spikes of data, especially when a huge music festival or a major playoff game on a sale. So the data doesn't trickle in. It hits like a tidal wave. So, and especially in the ticketing industry, a dropped message in a Kafka stream, so Kafka stream is nothing but real-time message streams from point A to point B. That would be a major drop-down, especially for the downstream databases or downstream systems. So that also means it might get kicked off a checked message for a fan. The stakes are high, and the data values are massive. Earlier in my career, when I started, I used to think that my job was to just write code and move data from point A to point B. I assumed the job would be easy. We would be just getting a JSON payloads in production and always, look exactly the way they did in the staging environments. So I assumed the upstream software engineers never make a mistake. But I was wrong. When it came into the real-time scenarios, we used to get a lot of issues, especially from when the change has been made in upstream. So today, I'm going to talk about that, making the data pipelines realistic. So the production environments are a little bit chaotic and unpredictable. So learning that lesson the harder way usually happens in the middle of night. How many of you agree that? Yeah. So today, I will especially talk about sleep. Yes, you heard that right? How to stop losing it. So welcome to Data Engineer Survival Guide, where we talk about writing the data pipelines that actually survives the chaos. So imagine scenario, the 3 a.m. phone call, your phone keeps buzzing and wake you up. Maybe a pager duty is screaming at you to wake you up, and a critical pipeline fails silently due to an upstream change. They change, maybe the upstream has changed a field without informing you, and the entire pipeline failed. So, for example, there was an integer that came up, the field that was integer initially, that came up suddenly as string. So you drag yourself to your laptop, looking at the logs. Maybe after an hour, you'll know that you'll get the culprit, that it was due to an upstream change. So the reason these catastrophic failures happen is because of a mindset issue. Meaning, A lot of people assume data engineering is just writing scripts, writing notebook scripts, but it's not. It's more of understanding what you write and making sure infrastructure is caught up with what you write. So it comes down to be scripting versus engineering. You have to learn engineering. So when we write scripts, we rely on implicit schemas, dynamic typing, and we build entirely for the happy path because we never put that hard path in our mind. But engineering requires explicit contracts, strict type hinting, and building a resiliency in what we write. So to ground this, let's look at a typical streaming architecture where, we get an upstream producer produces the JSON events, just in case, the JSON events. So I'm from a ticketing industry company, so let's say ticket sales. And there would be a Python consumer which consumes the data from the producer and pass on to the downstream. Everything looks good. Kafka is solid, and the downstream, let's say downstream is a Snowflake database. That is good. The major problem will be in the Python consumer, exactly where the transformation layer or the logic includes. So the infrastructure is usually fine. Things break in the middle at the Python transformation layer. So let's look at the anatomy of that failure. So this is the standard Python code. We defined our process ticket event, and we pull the transaction ID out of it. Then we hit the danger one. That is implicit trust in this schema. So look at the highlighted line over here, the tax amount, the calculation of tax amount. We extract price out of payload and multiply with a number. So this code is a ticking time bomb. What if the price is a string? We would encounter a type error because it couldn't multiply with a number. So it basically it takes the entire pipeline down due to a simple and stupid mistake. I would say that way. So we must shift to a survival, I would call a survival tactic, enforcing contracts with Pydantic. So if the data is the lifeboat of our system, we need a bouncer at the door. That is defining the contract using Pydantic model to enforce data shapes at the boundary. Instead of the raw dictionaries, we define a strict class naming. In this case, we named it ticket event. Inheriting from a base model, we write an explicit contract saying that transaction ID must be a string, and the price must be a float. And maybe we can also use that a field parameter that it should be greater than 0. So, and maybe an extra parameter saying isVIP is a Boolean and defaulting it to false. But what if the data is completely unparsable? So we build the safe consumer for catching the validation errors before they crash the application. So look at this try and except block. First, we validate and coerce at the boundary. We pass the raw payload into our ticket event model. If it fails, we catch the validation error, so it will fail gracefully but not fatally. So we log the schema violation over there if we catch any exceptions, and crucially, we quarantine the bad data by routing it to somewhere else. That somewhere else is nothing but a dead letter queue. In short form, it's DLQ. So DLQ is the secret to isolate the failures and to maintain the resiliency and the pipeline integrity. So the golden rule are never drop bad data silently, and route that failed payloads to a dedicated DLQ topic. And let's say we maintain a 60-day retention period on the DLQ topic for auditing and also replaying the data. So the DLQ acts as a quarantine zone, providing safe storage for the replay so you can sleep through the night and maybe fix it on the next day in the morning. So to summarize the first major shift, the ingestion boundary is a front line of the pipeline resilience, and we never trust the upstream data, and you catch your validation error at the Kafka consumer, and route those bad records to a dead letter queue instead of crashing the app into the isolation failures. So now, enforcing contracts brings us to our next hurdle, that is testing. Decoupling the input, the I/O, from the logic is the secret to testable data pipelines. So the I/O layer handles reading from Kafka and writing it to the databases, and handling the network retries as well. So it shouldn't be aware of the business logic. It just needs to handle the data coming in from Kafka. So the business logic should be pure Python functions consuming the Pydantic models and applying the business logic and returning the dictionaries. Here comes the next one. So by isolating input-output from a pure transformation logic, we unlock the survival tactic 2, that is the testing without the cloud. So look at this pytest function testing our calculation of the totals logic. First, we create the model in memory. Here, we don't need any Kafka. We pass a mock ticket event with a price, let's say of 100. And second, we test the pure transformation by passing the mock event to our function. So finally, we verify the business logic, matches our expected total, and you can run hundreds of these tests within milliseconds. So after that, we have our Pydantic models in place. We have our testing in place. Next would be our survival tactic 3, that is the structured observability. So moving beyond the logs to actionable telemetry. Let's say the print statements are only acceptable until certain number of memory. But if we have around if we are handling million records in an hour, it would be really hard to read all the statements. So I would say print statements are really a sin for data engineering, because if the engineers don't log correctly, we have to go through all the records, all the logs, and find out what's actually going on. So that's why we must implement a JSON formatted structured logging. So we need to inject the context to understand where the error came from and how it happened. Just like when I say injecting the context, it would be like transaction IDs, maybe row numbers, to trace the dropped records instantly. So I would say context is everything. After tracing the error is a part, and identifying the context is the next part. So we are replacing the plain text with a queryable JSON. Let's look at this example payload. Every time a failure happens, we output the timestamp, the error level, the exact transaction ID, the error type, and the specific message that input should be a value number in this case. So, and the raw payload as well that caused the actual failure. So the structured observability takes debugging from hours to seconds because you inject the transaction ID into the every log entry. You can simply query your log aggregator. Let's say the downstream team came up, hey, what happened to this transaction ID? We don't see that in the Snowflake. You would just go to your Datadog or any other log aggregator. You just find the transaction ID in the logs and identify why it failed, when it failed, and where it went. Obviously, we have set up a DLQ, so the message would land in the DLQ topic. Then you will instantly see the schema violation that caused the actual drop. Yeah, so to sum it up, our job as a data engineer is to maintain and manage the complexity of data. So I would say stop writing the scripts and start building software. So the 3 survival tactics which I talked about are enforcing the contracts with Pydantic, isolate and test with PyTest, and log those context using JSON. So implementing these will definitely help you guys whenever you're handling the data, and your pipelines will survive even though if some error happens. And especially, you wouldn't be requiring to wake up in the midnights. So that is all about it. Thank you so much for your time, and I will be open for the questions.
All right. I will say I was watching the chat and kind of watching the room and heard a lot of you've got people motivated. So that's awesome. So far, one question. Do these practices also help build some resilience against injection attacks?
No. So this is something when inside the data streams. So I would say it wouldn't, it is not a relevant question over here. But ingestion attacks are something, within the boundary of the company. So I would say it's not.
Fair. All right.
This is just to handle the data validation errors when the data is coming from the upstream.
Yeah. I was over there cheering, talking about logging with context. I think every one of us has at some point learned the pain of not putting enough data in the logs, whether it's data engineering or anything else. So awesome. That is all I've got on questions. Thank you so much. If anyone has more.
Thank you so much, guys.
Yeah.
Yeah.